Hello, let's go today through um, that question 408 valid word abbreviation. It's from the meta list. Um, in this problem, we need to validate if abbreviation um, is a valid abbreviation according to um, those rules. So those abbreviations uh, need you can't have you can't replace substrings which are next to each other with like separate numbers. You can have leading zeros. Um, yeah, no empty strings, no leading zeros. Um, so how can we do it? Sort of the easiest way is to essentially compare. That question is not about any specific algorithm. It's pretty much about just comparing, one, and if um, that particular string would equal to that abbreviation. Now, how can we do it? We can have one pointer pointing to the first word, and another pointer pointing to the other word. And now, then we need to have certain conditions to validate those strings. Yeah. So now I will be iterating through the for our abbreviation, because we need to see, like, we need to be extracting all those numbers. We need to keep track if characters are matching. So now we would start at I, and at this moment what we need to do is we need to check if current pointer which points to the original word, is it matching our character. So let's say I would have word index here, and here we would have abbreviation index. Okay, and no, right now it's gonna be pointing to first character. They both matching. Okay, so we can just move on. But then there is an interesting situation. Yeah? Then we have digit, we have a number. If there's a number, we need to parse it, yeah, because that's the part which is abbreviated. Okay, so yeah, we're gonna essentially iterate through the like entire part where there are digits, and in that way we're gonna extract that 12. Now, since we extracted 12, we can move our word index pointer by 12 places. So let's mark those indexes. So well, and so on. So now we would end up essentially at so that's 9, that's 10, that's 11. We would end up at 12 plus 1, which is current, which is 13th place. And that's 9, 10, 11, 12, 13. Okay. So we are here. And then on next iteration we're gonna see that there's regular character here, and they're matching actually, so we can move them forward. And again, they're matching. Z is matching with original, so we can move it. Then we have digit M. So again, we need to extract that digit and then move by 4 places. So we can move 1, 2, 3, 4. Okay, and we're gonna move that one, and then those two characters are matching. So yeah, we can just move forward, and wherever we whenever we iterate over entire string, we can there's nothing else to check, so we can return true if we arrive at the end of both. Yeah, so if we iterated over both. So for example, in this situation it will be a little bit different. So here is a situation where we need to return false, and yeah, we'll start our indexes here, and okay, A's are matching. Okay, then we need to extract 2. Okay, so that's where things get interesting, because now, okay, we're gonna move from position 1 to from index 1 to index 3. Okay, 1 plus 2 is 3. Yes, we're gonna move here. 1, 2, 3. Okay, we just good, and we process that number, and then it's good as well. But then they're not matching, yeah? So yeah, we need to return false. Just L here. If we had a situation where, let's say that is matching, but let's say that one original has one more character. So now, okay, they're matching, but now we're gonna iterate over entire abbreviation, but we still haven't finished. Let's say there's more characters. We still haven't finished our original. Yeah? In that way, it's also invalid abbreviation. Yeah? Valid abbreviation would have all those e's. So essentially, that's what's the problem. That's the problem. There's no any specific algorithm. It's not easy problem, because there's just so many edge cases to keep in mind. But yeah, it's just about following that logic. So let's start. First thing which I like to do is I'm gonna have that set of digits just to be able. It will allow me to very easily check if something is a digit or not. Okay, and then we'll be iterating over our words, and I'm gonna have, let's say, word index pointing to 0, and I'm gonna have my abbreviation index also pointing to 0. And then while both of them if we haven't iterated through we haven't finished any of them, so if word index is less than word length, and abbreviation index is smaller than abbreviation length, then our current character current abbreviation character from abbreviation string will be abbreviation add. Now if it's if it's not a GT, so let's first focus on easier part. Let's first focus on what we do if something is not a digit. So we can have if check if digits doesn't have that kind of character. Okay, it means it's not a digit. Okay? And then we can do something. If it's not a digit, then if they're not matching, okay, we need to return false. Otherwise, we can just go forward. So now, if current character is not equal to word at word index, we need to return false because they're not matching. like we had in example 2. I was not matching with it. But otherwise they're matching, so we need to just go further. Okay, so that's first situation. Second situation is that we actually have a number, so we need to process that full number. We don't know how long it is. So let's do it. We can essentially say that while our abbreviation index is still smaller than abbreviation dot length, and we have our digits has our abbreviation at abbreviation dot length. We can keep increasing that abbreviation, and start of our number start of number is at abbreviation I, okay, and end will be somewhere here. So then our number, we can get it by we can convert that into number and can just slice it out of that string. So we can say abbreviation dot slice start and end will be abbreviation index. Okay, and that's great. And yeah, so now what we need to do with that number, we need to essentially what we were doing before. Yeah, we extracted the number, and then we from abbreviation string, and then we moved our original our word index pointing to our original string by that many places. Okay, and now so that's what we're gonna do. Word index plus equal number. We could have like a if check, like if it goes out of the bounds, we can return false here. But that's not necessary because we have that condition in our while loop. So that's why there'll be a little bit of repetition. But that's why we're going to essentially at the end check if we if we iterate over both, if we iterated fully over both. So if abbreviation index is equal to abbreviation dot length and word index is equal to word dot length. Okay, then that means we validated everything, and everything was matching. Everything was matching in terms of a correct the same characters at the same places relatively, and also when it comes to the amount of the amount of letters covered by those numbers. So let's see if that's working. If that's working, let's commit that. Okay, it haven't worked. Let's see why. And that's one of them. That's one of the conditions. One of the conditions is that if we have leading 0, then it doesn't count as a. It should be considered as invalid. So what we can do is that we can say actually here that already at this point that if abbreviation at abbreviation index, if that's 0, then it's invalid because we don't want leading zeros, and we don't want to also replace empty substrings. Then false. Okay. Yeah, that worked. Okay, and yeah, when it comes to time and space complexity, so from time perspective, it would be a linear algorithm of n, where n is the length of the which is the length of the longest string. Yeah, the has method is constant space, because set works as a map essentially. Yeah, we may have here we have that inner loop, but it will be that loop will not cause our algorithm to go over the same characters over and over again. So it's still linear time complexity. When it comes to space, so we have those digits here, but it's constant. Yeah? They never change. We don't add anything to that set, and we don't keep anything else in the storage. Yeah, so that will be pretty much it. Yeah, thank you for listening. Yeah, and see you next time.